we are going to start on endogenous growth problem. We are going to cut the crap and slowly moving towards a more realistic description of how and why nations grow and what explains growth patterns. Today I am going to talk about two seminal models. These will set the stage for further examples. The arithmetic is more or less standard, and as you will see and appreciate more and more again, actually the whole idea depends on certain interferences and some mathematical conditions. And as long as these mathematical conditions are met, you can come up with any story to sustain your modeling effort. Now let me remind you our problem. So first of all, we will be talking about endogenizing growth. By endogenous growth, we mean that the economic machine creates inner conditions to generate perpetual growth without the need for assuming something from outside, such as technological change, such as population growth, things that we cannot explain. That is, whatever the source of growth will be inherent into the economic machine we are talking about. Now, to remind you, the main problem from the point of view of neoclassical economics, the whole problem arises from the notion that the profit rate, gross or net, it's not that important, depends on the marginal product of capital. That the return to capital, profit rate, is equal to the marginal product of capital. Secondly, the marginal product of capital is characterized typically by diminishing returns to capital. So these two premises together, the fact that production function is diminishing returns is necessary but not sufficient. You have to add the assumption that the profit rate, the return to your investment, is equal to the marginal product. In Marx or in Ricardo, you can generate a production function with diminishing productivity of capital. But if you keep profit rate aside from this picture, if you determine the profit rate from somewhere else, the fact that there are diminishing returns in the production function does not cause any problem. The problem arises when you say that the net profit rate is equal to the derivative of the production function. If you have a depreciation, fine. If you don't, that's fine. But the fact that f prime, the second derivative, is negative, that is, it is diminishing, together with the equality of the profit rate with the marginal product, which is diminishing over time, causes the growth process to come to a halt. Because people will be investing in return for a profit. If the profit rate is falling, eventually people will not invest in capital. Why should you? Why should you invest in something that will not bring positive profits? So this is the essence of the problem. In pure arithmetics, the whole problem can be narrated for an example. If, for example, the production F is Cobb-Douglas type, A k to the power alpha. This arithmetic boils down to assuming that alpha is less than 1. That is, k is subject to diminishing returns. If we take the derivative of this function with respect to k, then the second derivative will be a negative value. So, since Cobb-Douglas is a very common, popular technology that we are going to use here and there, typically the whole problem boils down in remedying this. That is, the reason that in the long run growth is going to 0 is due to the fact that alpha is less than 1. That is pure technician's way of looking at the problem. An economist's explanation is this one. This is the numeric representation of the main essence of the problem. In this country, I cannot be modest, probably you are among the few people who argues that in a neoclassical growth, there is no positive growth under steady state. Many people, many students will say that it is due to diminishing returns. This is not enough. There are diminishing returns, but then you have to have this. Profit rate is equal to the marginal product of capital. This is so obvious for mainstream that people tend to take it as given. But as you have seen, there are numerous models, there are hybrid models, there are different technologies that will break this link. This is not a rule written on stone. This is an assumption of the neoclassical world. These two together, or alpha less than 1, makes that in the long run growth is 0. But that is the problem. So, just to remind you, remember, typically there are 3 broad rules to solve this zero growth problem, or to how to endogenize this process in the long run. One, brutal force. Brutal solution. Rebello, 1990. Alpha is less than 1. Come on, alpha is alpha. Make alpha equal to 1. But, however, forget it. Alpha is 1. Is your problem solved? Yes. Then move ahead. Curiosity kills the cat. There is no further questions, buts, howevers. On the other hand, if you want to solve the problem, just do it. That's like assume alpha is 1. How can it be 1? How can all factors of production, labor, land, government, institutions, things that accrue as factors of production are all ruled out, and you talk only from capital? Well, as I always say, first be as a good arithmetician, solve your problem mathematically, show that this indeed solves it, then go back, shut the curtains, put some light music, have your favorite drink, daydream, how you can put this assumption into economic terms. Create things like human capital, that capital is, after all, the essence of the whole capitalism, that's what we are referring. Invent something. That can be done. But first of all, this is the so-called AK model from Rebello that you are all masters at. There isn't much ingenuity about this. It solves the problem, and we can leave it as it is. Secondly, and that's what I shall be doing today, is add externalities. Add external somethings. These somethings are anything that when you add to this function something, some x, is external to the system. You cannot control it, but it is present. And it is external to the right degree, meaning that I have implicitly a beta on top. K is capital per labor. So there is labor here, little k, capital per labor to the alpha, and something to the beta, such that alpha plus beta is 1, meaning that something operates in such a lucky and such a strategic fashion that it makes private capital per labor, private capital, act as if it is of constant returns to capital. That is, F double prime is not negative. F prime is constant. So profit rate becomes constant, and if profit rate becomes constant, then we have a constant amount of investment ongoing into perpetuity. These somethings could be human capital. It is not under the control of the capitalist. It is you. You are going to pay salaries, you are going to seek for jobs, but human brain is hopefully your brain. It's not working under someone else's command. It can be used for a profit of someone else's, but it is still an external to the firm. It can be something like a public strategic public capital. It can be institutions, Daron Acemoğlu and other people. It can be conglomeration effects that we shall see in a moment due to Krugman and Romer and Mankiw. Anything of that sort. Just to complete the picture, the third is to work through what we call technology or knowledge or research and development index A. We will work through endogenize A. That is, make technology or knowledge or R&D or ideas, all synonym words, whatever A is accounting for, knowledge, ideas, R&D, blueprints, make it an economic good. Technology is just like apples and bananas, is an economic good. There is a supply of technology, demand for technology, there is a market for technology, a price for technology, and you create and produce technology using resources, just like you produce apple using resources. Endogenize A by treating it as an econ good, economic good that is. Just like any other economic good, but it will have certain properties. So these are broadly 3 rules to solve for endogenous, yes. You must have seen this in Thursday in more detail with Gökberk. Otherwise, you have created a lot of opportunities. How the AK model brutally solves this problem. It's obvious there, so I'm not going to spend more time on it. And I will give you a series of examples on creating endogenous growth from external economies of size. This is the plan for today. Does this sound enjoyable, exciting? Worth spending another hour and a half here? Any questions, comments? Anything unclear on why we are gathered here this afternoon? Okay. Here is the economy based on what we call conglomeration effects. Türkçesi nedir bu conglomeration'ın? Şimdi bir şey söyleyeceğim. Emre bunu delete edebilir misin? Rektör Bey'e gidin. Erinç Bey arada sırada bunların Türkçesi nedir diye bize soruyor. Refet Hoca da aynı şeyi yapıyor. Biz bunu bilmiyoruz. Sonra da iş görüşmelerimizde, meslek yaşamımızda sıkıntıya uğrayacağımızdan endişe ediyoruz deyin. Rektör Bey. Veya herhangi bir Bilkent büyüğüne. Ya ben sana yani nasıl argü edeceğini söylemiyorum. All I am saying is that say this sentence or just write an email. You can put our names, Refet Hoca, Erinç Bey, your other favorite econ department professors. Hopefully we are going to create an environment where when I say conglomeration, you will instantly say kümelenme. Bravo. Biliyorsunuz. Bravo. Ama işte yani çok güzel. Kümelenme etkileri. Şimdi kümelenme nedir? Cluster. There are clusters of producers together. Very typical, very classic example is Silicon Valley. Or in agriculture and food processing, Punjab Valley in Pakistan. In Turkey, İstanbul, Bursa, Kocaeli, Yalova, Çekmeköy, Eskişehir, that region. But not Elazığ, Sivas, Mardin, Muş, Malatya, for example. So the producers are clustered together. This had been popularized by Krugman's writings, but the original idea that we could have traced as far back, and I'm sure the idea may go all the way back to medieval times or biblical times, but the main seminal idea comes from Arrow 1962, as early as or as late from today as that, and this is more or less learning by doing or learning by learning ideas. As I said, first do the arithmetics, then you will create words for it. You will create fancy things like conglomeration or spillover or clusters. There will be English is a powerful language. There will be words to narrate what you are doing right to solve this problem. The economy is consisting of producers where output Q is produced by capital, labor. Pardon, let me just check this. I don't want to get confused here. Okay. Labor and conglomeration. And conglomeration, I'm going to write a big K to something like eta. The big K is all firms operating nearby your vicinity. Tofaş is in Bursa. Next to it there is Renault. A couple of 100 kilometers away there is Ford. Then all there are the side engineering, the small merchants, manufacturers, tire suppliers, etc., etc. And they typically have dinners together. Their children go to the same school. They meet. They share experiences. They learn, and they share what they learn. And this creates an external environment to the extent that the next day when they come to work,
they come with added experience of their colleagues who had been around. That is the same kind of picture. That people share their experiences, they learn, they observe, and this creates externality. This is not paid for by the firm. This is something like coming from social relations. It is not an economic activity. It's a social activity making productivity of private capital externally richer. And as the deity will go, we will assume beta plus eta equals 1. You have to make these assumptions as small, as unnoticeable as possible, because this will turn out to be crucial, and you don't want to ruin your sophisticated model because of something that will be caught easily. This is the art of modeling. The things that doesn't make much of an importance, you have to highlight and spend pages until the reader says, okay, yes, and do not bother it. And then you sneak this sort of a thing in the footnote, and it will turn out to be so crucial, but you will just get away with it. So I'm just writing it as small as possible. And whomever can read this, and whomever cannot read, say that, Hoca had written it in small words, then it's not important. That is the idea, both in research and teaching, in social relations as well. Right? So the externality is of the right size. Beta plus eta could be any number, 2, 0.3. If it is less than 1, this whole thing will not work. If it is greater than 1, you will now have exploding economy. You will go into increasing returns. You will not have any equilibrium. It has to be just equal to 1, that like the AK model, like this alpha plus beta, so that there will be constant returns. Not decreasing, not increasing, just the right size. And this big K is simply summation from 1 to m of firms' capital. There are m firms. M could be any number, 3, 4, 5, 6, anything bigger than 1. So there are m firms, and the fact that there are firms neighboring, they support each other. As before, there is a consumer who is maximizing from 0 to infinity. Pardon. Rho mu kullandım burada da? Rho kullanmışım, tamam. We are using rho, right? Minus rho. Rho is the subjective discount rate. We can assume of a population growth, as before. We don't need technical change because we are creating conditions for technical change. So A dot X endogenous exogenous technical change is ruled out. And the utility function is c to the power 1 minus theta. The constant intertemporal elasticity of substitution utility function that we have introduced last week. This economy tries to maximize this thing subject to the technology. So this thing is to be maximized over time, maximize utility, subject to the production activities of the economy, which is this thing. I'm going to write in per capita terms, k to the power, k is capital over L times bk theta. This is output minus consumption. there is no depreciation, there is no population growth, and the economy maximizes utility subject to its technology constraint. This is output minus consumption. So this entity is savings. Subject to the constraint on savings, savings adding to capital, or private capital here, capital per labor, and the economy operates through time in this fashion. The Hamiltonian of this thing, H, is e to the power rho t utility function times the Hamiltonian multiplier mu. And here, I didn't write the capital accumulation condition. Subject to k dot. Capital changes with this distance. Capital increases by savings. There is no depreciation and there is no population. If you want add depreciation, it will be just a minus delta term. So this is output per labor minus consumption, which is equal to savings. Capital investment is increased by savings, and this is your constraint. So I put that constraint in, k to the power beta, this external k minus c. That is my cost state variable, the k dot variable. Is the economy understood? Çok yaşayın. We are maximizing the utility, the classic utility function, subject to what the economy produces minus consumption, that is subject to savings is being added to capital accumulation, subject to the capital accumulation constraint. I am maximizing a utility function and hoping that this will do my trick. The first order conditions of this problem, as you will recall, the derivative with respect to the objective variable should be 0. The derivative with respect to cost state variable should be equal to minus of the Hamiltonian multiplier. This is standard as long as you have this thing right, then applying these first order conditions are straightforward. From the first order condition, we will always get e to the power minus rho t, and c to the power minus t is equal to mu. And from the second order condition, we will have mu beta k to the power beta minus 1. This giant thing to the power eta is equal to minus mu dot. This one, yes, this is minus mu dot. It's funny, it is unconventional, but that is the first order condition. It resembles the so-called Lagrangian multiplier and static constraint optimization, but in a dynamic sense, it is equal to, typically you will take derivative with respect to mu and set it equal to 0, but they are not in the Lagrangian operators. We are taking a derivative with respect to the cost state variable, the variable that is changing over time. And setting its derivative to minus of the Hamiltonian multiplier rate of change. And minus mu dot over mu from here is beta little k to the power beta minus 1 with capital to the power eta. And from the first condition above, I log differentiate this entity. And I have mentioned that trick of rather than doing it both simultaneous, taking a logarithm and differentiation together, which could be confusing. I typically do it in 2 steps. Take logarithm, that is minus rho t ln e minus theta ln c is equal to ln b, the logarithm in natural terms. Ln e is 1. So secondly, take derivative with respect to t, that is minus rho minus theta c dot over c is equal to mu dot over mu. The first part of all these class of problems, of these Hamiltonians, will be always the same. We are using the same utility function over and over again with the same variables. There is a dynasty with a perfect foresight. The guy is maximizing the utility over consumption. And with this standard utility function, the log differential will always create this sort of a first order condition, or the minus mu dot over mu, if you change signs, will be theta c dot over c plus rho. So I have a minus mu dot over mu from the second equation. I have a minus mu dot over mu from the first equation, and you will combine it and solve. Matematik takip ediyorsunuz değil mi? Bir endişe, bir kaygı. Biraz stres olmasında fayda var yani, yoksa uyuyup gideceksiniz ama yani iyi. So combine the both sides together. Minus mu dot over mu equals minus mu dot over mu from the first equation, from the second equation, to get the following. C dot over c, that I am going to call the growth rate of this economy. Change in consumption divided by level of consumption. That is the rate of change of consumption. Rate of growth of consumption, which, if we are talking in equilibrium under steady state, everything must be growing at the same rate. So I can easily take this. I will call the growth rate G, not to confuse it with other things. That's the growth rate of this economy. It is equal to what? It's equal to 1 over theta beta little k to the power beta minus 1. And let me change this way around. Minus 1 minus beta times this big conglomeration thing minus rho. If there were depreciation, there will be a minus delta here as well. You'll be just carrying it around. And it's just a pure number of accounting that I'm just taking away. Okay? This thing, observe, is the marginal product of K. This marginal product is diminishing if you don't have this. We are back to the standard Cobb-Douglas problem. Now this marginal product has an added term, but it operates in an external way such that this is the story, right? These are, suppose that this is fiat. This is Alfa Romeo. This is Toyota. This is devrim arabası. Okay. These are all different individual firms. K1, K2, K3, K4. And all of them, Fiat works with its own private capital to the power beta. But the fact that next to it are all these firms together, this is the sum of them. And this is this whole K. So the whole geography is what we call conglomeration or cluster. And its added effect to what Fiat is producing is what it has under its own expertise plus the conglomeration effect. Now the trick is the manager of the Fiat factory cannot control what others are doing. It has to take them as given. The more activity they have, the better off Fiat is. But it cannot choose strategically what the rivals should be doing. It has to take their decisions as given, and that is called the externality. What are they doing is simply accepted. So that is the reason of the external effects over here. And what we shall assume, for simplicity, that all of these firms are identical. That is, this summation, I from 1 to m of ki, is simply m times k. There are m times k external effects. They are all identical firms. So if this total k is m times little k's, if all of them were identical, rather than this summation, I can write them as m. Over here, I will rewrite this and have this sort of an economy. C that over C, my growth rate is 1 over theta times beta k to the power minus 1 minus beta. And for the conglomeration, k, I write m times k. There are m firms. So this is m times little k to the power eta minus rho. M is a number, 3, 4, 5, 6, whatever. K is what they are producing in terms of capital. And after a simple rewriting of terms, we will have this entity, moving this k to the power eta to the other side. Şurası önemli, şurası tekrar yazayım, okunmasını istiyorum. K to the power minus 1 minus beta minus eta times m minus rho. What happened? Now, first of all, observe theta is a number, parameter. Beta is a number, parameter. M, number of firms, parameter. Theta, parameter, and rho. The only thing that is a variable here is k. And the power of k is 1, forget this sign for a moment, 1 minus beta minus eta. Now you have to assume that beta plus eta is 1. Otherwise, this will not work. And I have done it already. Okay? This turns out to be the main assumption that solves this model. You spent a couple of pages in narrating that, and if you swallow this, then this term goes to 1, and the endogenous growth rate of the economy will be 1 over theta, beta, m to the power eta minus rho. And this will be the constant rate of growth of this economy. In this world, what is crucial is, as you see, this m to the power eta, or over here, again, once you get rid of the term, m is the number of firms. So the more producers, the more will be the conglomeration effects. This economy's growth rate is something of this sort. Here you put m, the number of firms, okay, and here the growth rate. At 2 firms, that's the growth rate. If you have another firm, then all of a sudden the growth rate jumps. If you have one more firm, the growth rate jumps. All constant rates, but at each round, once you add whatever theta is, that number to the power theta, the growth rate all of a sudden jumps. There isn't much of a transition dynamics. If you open up a new factory, you have higher growth rate. If someone goes bankrupt, the growth rate comes down. And that is the most unrealistic, undesirable side of this model. There is one more usage of this idea, and this is used by Krugman's strategic trade policy idea. That is, if you open up to foreign trade and invite foreign firms in through FDI or imports of strategic raw materials or strategic capital goods like machinery, technology-intensive goods, whatever, then it acts as if the number of firms domestically is increasing. So this number may increase by foreign trade or FDI or foreign ideas, foreign this, foreign that, foreign cultures, foreign tourists, foreign capital, whatever. The more you open up, the more you trade, it acts as if the number of foreign firms entering the domestic economy increases. So Krugman's teaching was that if you supplement domestic production by foreign trade in investment, in machinery, in ideas, in tourists, whatever, then it acts as a conglomeration effect in boosting up growth. And you can construct ideas on foreign trade modeling, strategic trade policy, FDI, which kind of FDI? Are you going to invite in potato chips or computer chips, guns or gums or that sort of a thing? We are going to add something of the correct size, and that's something we are going to call is a strategic public good. Or public capital, rather, not public good. Strategic public capital, that I am going to use G. everything in per capita terms. Here is the deity. There are firms, and firms produce national income per labor, with the technology that, let me get these things straight. I have to use A here. With the technology that private individual firms capital per labor to the power 1 minus alpha, government strategic public capital to the power alpha times the level of state-of-the-art technology in the economy. This strategic public capital could be anything such as airports, highways, some strategic machinery that the private firm is using. It is up to the government decision to produce an airport or a machinery or whatever. Thus, the presence of G is external to the presence of K. The firm manager cannot choose the amount of G, but it enjoys its presence. There is an airport, the firm produces its products, using the airport, it transports them. But the firm cannot decide upon the size of the airport, whether the airport is to the north or to the south, is nearby or farther away. It is not a choice variable. But the fact that it is out there, and again, I don't have to assume it or I don't have to put it in your eyes. Observe that the size of the public capital externality is of the correct magnitude. In last hour's language, it is as if k to the power beta, something to the power eta. And beta plus eta had to be assumed to be 1. Now I made this openly, without creating much of a discussion about this. This so happens that there is a public capital producing externalities, private capital producing private goods, and again, there is a consumer doing the same things over and over again, maximizes some utility. Sorry, şunu çıkarmayı unuttum. With some discount factor. Sonra notlarınıza bakmadan söyleyin. Nedir utility fonksiyonu? Bravo, bravo, bravo, bravo. Tek kelimeyle bravo. Akşam gözlerinizi kapatıyorsunuz. Kodladınız. Q eşittir K to the power alpha to the beta. CAS, U, C to the power eta. Right. Bilkent Üniversitesi'nden diplomanızı aldığınız zaman ertesi gün bunlar rüyanızdan her gün sizi haunt edecek. All right. So this is our utility function that you want to maximize. What is it subject to? Maximize this subject to our technology constraint. Subject to capital is changing, K dot, right? It will change by savings. Can you tell me how I write savings? Output minus consumption. Output is this character over here, A, K to the power 1 minus alpha, G to the power alpha, minus C. However, in this economy, there is public capital. This is a notation for private capital. Private capital is output minus consumption. That is private savings. But I have to produce public capital as well. You are on the right track, but there is a better shortcut. How does public capital financed? Government expenditures, all right? Taxes. So if you are not want to complicate your life by assuming a central bank printing money, a treasury printing public assets or public bonds or treasury bonds, foreign borrowing, current account deficit, exchange rate, vesaire, vesaire. Just since we are abstaining from all these issues, you may simply say that government is financed by taxes. Well, where did these taxes come from? They will come from incomes. Tau is the tax rate out of national income. And it is simply equal to tau a k to the power 1 minus alpha g to the power alpha. National income times tax rate. This is the public sector total tax revenue or public disposable income. Buyurun.
Since the government is collecting taxes, shouldn't we include 1 minus tau?
Exactly, exactly. That's who is paying these taxes? Private sector. Then private disposable income will be, very good point, will be over here, 1 minus tau. Private income minus private consumption equals private savings, and that goes to private capital investment. Public disposable income financed by tax rate out of GDP, and it is public expenditures which go to public capital. Government budget is in always equilibrium. Government expenditures is equal to tax revenues. Who pays the tax? The private sector. Therefore, value of GDP minus taxes, we have private disposable income minus consumption is equal to savings. Savings go to capital investment. There is no difference. Gene aynı şeyi söyleyeceğim. Her ders bu artık tekrarlanıyor. Buna alışın. There is no difference between savings and investment. All right. So the Hamiltonian of this economy is, let me write it over here. H is e to the power rho t, and this thing that you have already, no t here, that you have already memorized, 1 minus theta plus mu and this is my co-state variable. G is also co-state variable, but I can rewrite the economy in inside, and let me do a let me do it later. Let me just use this thing as 1 minus tau a k to the power 1 minus alpha g to the power alpha minus c. Again, I am taking out depreciation. If there is a depreciation, you put a minus delta k here and keep it until the last moment. But it just serves as an added identity. That is that's my economy. With the implicit constraint that G is equal to tau times Y. And I'm going to put it when the necessary time is due. So again, two first order conditions. The derivative with respect to your maximum C is equal to 0. The derivative with your cause state variable K dot is equal to minus of the Hamiltonian multiplier changing, minus mu dot. From here, the same problem, the same tricks, the same story, the same thing over and over again. The derivative is minus rho to the minus e to the power rho t, c to the power minus theta is equal to mu. And from here, now you already know that this is minus mu dot over mu is equal to rho plus theta c dot over c. Bunu ben neredeyse lise hayatımdan beri yapıyorum. Artık ezberledim. Ama siz bu ara stepi doldurmayı becerin. You take the logarithm, then the derivative, and you get a minus mu dot over mu here. From here, we have mu times 1 minus tau a 1 minus alpha k to the power minus alpha g to the power alpha is equal to minus of the mu dot. Which tells me that minus mu dot over mu is equal to 1 minus tau a 1 minus alpha k to the power minus alpha, g to the power alpha. Therefore, I'm going to write this as g over k to the power alpha. Now let's go back for a moment. We know that, as I said, G is always in equilibrium. That is, budget is always satisfied with equilibrium. Therefore, for G, I am going to use tau times y. And since G is equal to the tax rate times y, tax rate is equal to y divided by g. Or y is this thing, a k to the power 1 minus alpha, g to the power alpha divided by g. Or it is equal to tau a k over g to the power 1 minus alpha. This g goes down, and or this alpha comes down. Bunu böyle yapmasaydık. K to the power 1 minus alpha, g to the power alpha minus, I don't want it that way. G to the power 1 minus alpha. So g to the power 1 minus alpha is equal to.
Shouldn't be tau equal to g over y rather than y over g?
Tamam. That's why I'm confused. Exactly. Thank you. Tamam. Çok kusura bakmayın. Evet. Tau is equal to, yine aynı şeyi diyorum, g over y. Tamam. Kusura bakmayın. That's g to the power a k to the power 1 minus alpha, g to the power alpha. Çok teşekkürler. Tamam. So now tau is equal to g or tau times a, k to the power 1 minus alpha is equal to g to the power 1 minus alpha. Now I am safe. Thank you. Tamam, ben bir soluklanayım. Siz telaş olmayın. Şimdi artık düzeldi. Do we all agree that we have the... Her zaman dediğim gibi önce iyi bir aritmetikçi olun. İşinizi temiz yapın. Sonra iyi bir temiz data toplayın. İktisat ondan sonra. Okay, then I will get rid of this g, which is tau to the power 1 over 1 minus alpha, a to the power 1 over 1 minus alpha times k. And since I have here a term g over k, from what I have created from this exercise, I can rewrite g over k to the power alpha, this thing, so that I can replace it, will be equal to tau to the power alpha to the power 1 minus alpha, a to the power alpha over 1 minus alpha. And I will take these numbers and put it into this equation. Minus mu dot over mu is equal to these terms 1 minus tau, a, 1 minus alpha, g over k to the power alpha, which turned out to be tau to the power alpha minus alpha over alpha minus alpha, a to the power alpha 1 minus alpha. And it is also equal to this expression, theta c dot over c minus rho. Pardon, plus rho. This thing coming from the first order condition, this thing coming from the second first order condition. I have recreated an expression for this, got rid of g, is everything, everything is in tax units. And I have this growth rate for the economy. Let's call this again the equilibrium rate of growth of the economy, 1 over theta times 1 minus tau, a, and a to the power 1 minus alpha, 1 minus alpha. This is equal to 1 minus 1 plus alpha divided by 1 minus alpha. These characters drop out. So this will be alpha over 1 minus alpha. Did I get this right?
1 over 1 minus
Öyle mi? 1 eksi alfa 1 eksi. Pardon, evet doğru. Pardon, çok doğru. So I got rid of this. There is 1 minus alpha, and there is a tau alpha over 1 minus alpha. And there is the rho minus rho. This is it. Etkileyici mi? Not yet. This is the rate of growth of an economy with a strategic public good, public capital, financed in a fiscal neutral fashion where government expenditures is equal to tax revenues. There is no budget deficit. And the rate of growth of the economy, 1 over theta, a parameter, 1 minus tau. Tau is your tax rate, 20%, 30%, 40%, whatever your expenditures. A is level of technology. 1 minus alpha. 1 minus alpha comes from, keep in mind, this is, let me write over here. Income is this thing, A, k to the power 1 minus alpha, g to the power alpha. This is my production function. 1 minus alpha is the share of private capital in GDP. And then I have another tax term, n minus rho. So if you tell me the tax rate in this economy, suppose it's 30%, you put here 1 minus 0.3. A is the level of technology. It is not changing. I don't need it. And alpha, you can calibrate as you did in your homeworks and the midterm, etc. The share of private capital in GDP. The share of public capital is the rest. If you put in the numbers, you get one constant rate of growth. As you see here, there is no private capital. K has disappeared because I am adding an externality which is correcting for the diminishing tendency of the marginal product of private capital. The presence of public capital eliminates the diminishing rate of return pressures on private capital. Therefore, K disappears from the picture. Here is the marginal product of private capital, which is all in constant terms. Now, from then on, a final question that will interest us is what should be the size of the tax rate, tau? Right now, it's an arbitrary tax rate. And a rational government may choose tau optimally to maximize growth, which is equivalent to saying that to maximize consumption. Unutmayın, Karacaoğlan kuralları geçerli. At, namus, silah, isim. Biz bu dünyaya tüketim için geldik. So, a government would want to maximize consumption or equivalent to maximizing the rate of growth in this economy. And this is my growth rate. So I want to choose a tax rate to maximize the rate of growth. And this is my rate of growth over here. So choose a tax rate to maximize this entity. 1 minus tau, a to the power 1 minus alpha, times 1 minus alpha, tau to the power alpha minus alpha, minus rho. Now it turns out to be a long expression, but its derivative is actually very easy to find because taus are always linear. So if you do that, delta gamma delta tau, and set it equal to 0, this is what we will get. We will have 1 over tau a derivative with respect to minus tau is minus of a to the power 1 over 1 minus alpha times 1 minus alpha tau to the power alpha minus alpha plus now the derivative with respect to this tau, this is alpha over 1 minus alpha tau alpha 1 minus alpha minus alpha. This is minus 1 over 1 minus alpha. Did I get this right? Bunu böyle bırakayım daha iyi olacak. Alpha 1 minus alpha minus 1 times 1 minus tau a to the power alpha minus alpha times 1 minus alpha is equal to 0. Şu alfa over 1 minus alfa değil. One over 1 minus alpha. Then this 1 over theta is equal to 0, that disappears. So I have a to the power 1 over 1 minus alpha, 1 minus alpha, tau to the power alpha 1 minus alpha is equal to alpha 1 minus alpha, tau to the power alpha 1 minus alpha minus 1 times 1 minus tau a to the power 1 minus alpha times 1 minus alpha. Now I have çok yaşayın. A couple of identical elements. This A and this A cancels out. This 1 minus alpha and this 1 minus alpha cancels out. Sizin de hocalarınız vardır böyle. Benim matematik hocalarının çoğu, iktisatçıların çoğu böyle olur. Hele bir ekonometri hocamız vardı. Cancels out, elinde bir silgi. Daha biz yazıyoruz. Bunları siler. Sonra pat diye bir şey kalır. Ben daha bu satırdayım. Ondan sonra da birbirinize konuşacağınıza tahtayı yazın diye bir de azar işitirsiniz. Öyle internet, kitap, mitap, defter falan filan yok. İşte tahtada gördüyseniz neyse o. Neyse. Tau to the power alpha minus alpha and this thing cancels out. This minus 1 remains. That's all. So from here I have 1 is equal to alpha divided by 1 minus alpha and tau to the power minus 1, or I can rewrite it as a denominator to the power tau, and this is 1 minus tau. To get this solution, let me write this over here. To get this solution, 1 minus alpha over alpha is equal to 1 minus tau over tau. Ne yaptık bu kadar işi? What are we after? We are trying to find out the size of tau, the optimal tax rate that will maximize the endogenously given growth rate of this economy. The question is big. You are a rational government confronted with this technology. You are not rational, but also a rule-abiding government where there is no fiscal deficits. Government expenditures is always equal to tax revenues. The budget is in balance. But at the end of the day, you are going to create conditions for endogenous, sustained, long-run equilibrium growth. But you have to choose how much you are going to impose taxes on this economy. The more taxes, the more public capital. But then the less is private disposable income. Less taxes, less government public capital, the less will be growth. So there is a trade-off. If you tax more, you grow faster, but you have less to consume. If you don't tax less, then you have a lot to consume, but out of a small rate of growth. So the optimal tax rate, after all this exercise, creates this condition, and the only solution that you will have is a tax rate to be equal to alpha. Surprise, surprise. But you knew this already from the days of Solow. This is the herkes haddini bilecek rule. If there is a government, if there is private capital, if there are workers, and if the main source of this growth in this economy is coming from public capital, its share from national income must be equal to the total savings and expenditures investment on public capital. Capitalists must save and invest, and they shouldn't consume. Government must collect taxes at the size of its share in national income, which is alpha, and then everything will be at its maximum rate. So whatever the contribution of the public capital to the GDP, that its share, alpha, must be entirely devoted to taxing and creating new public capital. And the optimal tau, if you want to put a star, is set at this thing. Meaning that if over here I use this thing, then the growth rate will be at its maximum with the maximum consumption possibilities. As you see, everything is in parameters. It creates a constant term. Everyone is happy. Consumption is maximized. Government is in balance. And this is another externally driven endogenous growth model. What we had done eventually, again, did a trick where this thing sums up to 1, creating constant returns to private capital. Now, you can add those some things to your satisfaction. If you are using a Cobb-Douglas technology, rather than G, you may have here a human capital of the relevant size, like a k to the private alpha, private 1 minus alpha, human capital. How is human capital produced? Yeah, what are you doing right now? Yeah, give me a break. You could have used this time working in a business environment, in factory, in whatever, but with less human capital. You are foregoing wages that you could have earned by working in the business, but you are using that time to produce more human capital. It is as if implicitly the opportunity cost is the wage rate that you could have earned out in the streets selling lemons in Ulus Çarşı Pazarı or Perşembe Pazarı, whatever. Rather than doing that, you are here foregoing that wage rate that you could have earned, the opportunity cost of being here, in addition to everything else. So this H could be produced by a wage rate times H. There is a market for human capital, so on and so forth. Just like the tax that is being used to create public capital, a wage rate is used to create human capital. The same logic, then there is an optimal human capital that's necessary for maximizing growth, so on and so forth. And rather than H, you can put in institutions. Institutions do not just fall from the sky. They have to be created. There are creation costs, costs of adjustment, transition, so on and so forth. And this more or less wraps up the main structure of externality-driven endogenous growth models. On Wednesday, I'm going to distribute back your exam questions. Before that, we will be posting in grades, either by tomorrow or Wednesday morning. I will just very quickly go over the exam. We are not going to do any net new lecturing. Next week, next Monday, I am going to start on the R&D-driven, knowledge-driven, Romanesque growth, and spend the rest of the semester with applications, with its narrations over it. Your homework is due on Wednesday. I will try to wrap up another homework for Wednesday for the upcoming weeks, and then we'll continue in that fashion. Anything I should be aware of from today? Peki, o zaman çarşamba günü görüşüyoruz.